9.2 notes, central and inscribed angles. What are the properties of central and inscribed angles? How can we use them to find missing measurements in circles? Got quite a few definitions here. You guys need to get down in your notes so that you have them. I'm not going to read over them. Pause the video and read over them and make sure that they get in your notes. Again, you can pause, rewind as much as you need, and we'll be constantly using these words, so you definitely need to know what they are. How to identify each of these parts in a circle. So remember, everything that's on my screen needs to go in your notes. So, first word, okay, center. So this is the center of the circle, kind of an obvious one. A chord is any segment that connects two endpoints of a circle. So this would be considered a chord right here that connects two endpoints, or the endpoints of that chord connect 2 points of the circle. That's considered a chord. A radius connects the center to the edge of the circle. This would be considered a radius. An inscribed angle. An inscribed angle is where the vertex is on the circle itself. This angle is an inscribed angle. The vertex is actually on the circle itself. We call that an inscribed angle. This is also another inscribed angle up here. This is also another inscribed angle up there. Those are called inscribed angles. Central angles are exactly what it sounds like. Central angles are in the center of the circle. So you can see here's the center of the circle. This angle right here in the center of the circle, we would call that a central angle. So it's really key that you understand the difference between a central angle and an inscribed angle. Okay? There's a difference between the two, and you need to know that. An intercepted arc is the arc that is intercepted by an angle. So for example, an arc is a distance around the circle. So let's look at this distance right here around the circle. This is called an arc. That is the intercepted arc of the central angle in which we talked about, this central angle here in the middle. It is also the intercepted arc of this inscribed angle down here. So you can see that the sides of the angle both intercept the endpoints of that arc to there, and then same thing, notice how the central angle is intercepting the same exact points. We call that the intercepted arc. What are the relationships between angles and arcs? So this is a really important information. Make sure you get all this down. A central angle, so this all needs to get down. A central angle is equal to the intercepted arc. Okay, so any central angle is equal to the arc that it intercepts. For example, let's say this central angle here, we'll call this 50 degrees. If this central angle is 50 degrees, then the arc at which it intercepts, arc AC, is also 50 degrees. We measure arcs in terms of degrees as well. Next, an inscribed angle is equal to half of the intercepted arc. So let's say down here, this angle, it would have to be 25 degrees. This inscribed angle down here, notice how it intercepts the same exact arc, right? As the central angle. Well, if that arc is 50 degrees, that means that the intercepted, or the inscribed angle of that intercepted arc is going to be exactly half of the measure, okay? Or the arc is going to be twice the measure of the inscribed angle. This is 50 degrees, this inscribed angle is exactly half the amount, 25 degrees. And that's what this information is saying in here. So let's do some examples. So again, pause the video as needed. All of these examples and the drawings need to be in your notes. This one says, find the measure. So M means measurement. And then this symbol up here means arc. So this means the measurement of arc PR. This is arc PR. And notice how it's already labeled X. Notice how the central angle in the center of the circle, that is not a very straight line, is intercepting arc PR. Notice how the central angle is 102 degrees. That means that the intercepted arc must also be 102 degrees, and we had learned that from the previous slide that we went over, right? The intercepted arc and a central angle is exactly the same measure. So it's as simple as that for that one. Example 2, again, I know I'm going pretty quick. Pause the video and rewind as needed. So you'll notice it says in this one, find the measurement of angle ABC. So let's find angle ABC. That's going to be this angle right here. So notice how this angle here is what we call an inscribed angle. It is not a central angle. Okay, it's an inscribed angle. Notice how that this angle is intercepting arc AC. What is the measurement of arc AC? We can see that the measurement of arc AC is 124 degrees. And we know from that slide that we went over that an inscribed angle is equal to half of the intercepted arc. So this angle ABC is exactly 1/2 of this intercepted arc measure. So we just take 124 and we want to divide it by 2. And you can use a calculator to do that, and it's also mental math as well. And you would get 62 degrees, and that is the measurement of that inscribed angle, 62 degrees. Example 3, again, needs to go in your notes. Notice how in example 3, it's saying find the measurement of arc AC. So this is arc AC right here. And it also wants us to find the measurement of angle ABC. So ABC is this angle right down here, right? So we can do that using the central angle that's given to us. So notice how they give us a central angle of 45 degrees. It is intercepting that arc AC, and we know that from that previous slide that the central angle is equal to the intercepted arc. So if the central angle is 45 degrees, then guess what? The intercepted arc AC, is also 45 degrees. Notice how the inscribed angle down here in which we're solving for, right, angle ABC, is also intercepting the same exact arc. That doesn't mean that they are the same. Remember the rule that inscribed angle is exactly 1/2 of the arc, just like we did on the previous question here, remember? So we know that this inscribed angle here is going to be exactly 1/2 of 45 degrees, or 45 divided by 2, and you should be getting 22.5 degrees. And the last example for our notes, again, pause the video, make sure it's copied down. This one's a little bit more extensive, but let's take a look. It looks like they want us to find a couple different things. We're going to find the measurement of arc EA, that's this arc. We're going to find the measurement of angle EOA. So angle EOA is right in here. That's angle EOA. We're going to find the measurement of angle EOC. EOC is going to be this angle right here, this entire angle, EOC. And then finally, we're going to find the measurement of arc EBC. So arc EBC is this arc here, EB, all the way around to C. So that's what we need to find right now. So let's go ahead and do that. First, I can see that 31 degrees right here is our given measurement. So let's start there. That is an inscribed angle. That is not a central angle. So let's find the arc that it intercepts. So notice how this inscribed angle is intercepting arc EA. As you can see, arc EA, right? Which means that that arc EA is twice the amount of that inscribed angle. 31 times 2 is 62 degrees, right? So that means that this arc right here is 62 degrees. Because that, remember, this inscribed angle right here is half of the amount of that arc, right? So we just do 31 times 2, and that'll give us that arc. So now that we have arc EA being 62 degrees, notice how this central angle right here, angle EOA, right, it is intercepting that arc, right? Do you see that? It's intercepting the same arc. So that means that that angle must also be 62 degrees. All right, so let's see. We have arc EA 62 degrees. That central angle, angle EOA, is also 62 degrees. There's a couple ways we could figure out the orange. We're finding the orange angle now, angle EOC. Two ways we can go about doing it. Notice how we have a straight line. Now you learned from IM1 that a straight line we should know is 180 degrees, right? This straight line is 180 degrees. So with that said, if we already know this part right here is 62 degrees, then the remaining of it is going to be 180 minus 62 degrees, right? So if I do that, 180 subtract 62 degrees, I get 118 degrees. So that tells me that this angle is 118 degrees. So I can mark that, 118 degrees. Another way you could figure that is all radiuses are the same length, right? So this radius right here is congruent to this radius right here, and we should be seeing the isosceles triangle. I'm highlighting it in red or outlining it in red. Well, then the base angles are the same, right? So if that's 31 degrees, then guess what? This angle over here is 31 degrees. And then we know that what? The angles of the inside of a triangle always add up to be 180 degrees, right? Well, if we know two of them, 31, we're just going to subtract both of those from 180. And you can see we get the same thing, 118 degrees. So there's two ways you can think about solving for that orange angle, angle EOC. Lastly is arc EBC. So we should know that a circle is 360 degrees, right? A half a circle, a straight line, is 180. The other half is 180. Together, if I add them together, I get 360 degrees, a full circle, right? So what we know is, I'm going to use purple here just to kind of differentiate. We know that we know the measurement from here to here. That's what we just figured, right? We know that that's 118 degrees, right? Well, if I continued all the way around, right, that's going to be the rest of the circle, this part right here. Let me highlight that in maybe orange. So we know that this part is 118, because that's what we just solved for. So the rest of it, you'll notice, is this arc, this intercepted arc right here. So we know that this arc here is 118 degrees, so the rest of it we're just going to subtract from 360. So 360 subtract 118 gives us 242 degrees.